So we're going to do another example pertaining to correlation and regression in chapter 9. Let X represent the average annual hours per person spent in traffic delays, and let Y represent the average annual gallons of fuel wasted per person in traffic delays. So take a minute, guys, to put the data in L1 and L2. Do you guys believe that there is a correlation or relationship between the hours you spent in traffic delay and the number of gallons wasted while in the car? You think the two relate with each other?
Yes.
Yes, definitely. Because when you are stuck in traffic, you are wasting gas, unless if you turn the engine off. I don't think most people don't do that because it will be difficult, just to go restart and then turn it off and then restart. Okay, the first question. Find the value of the correlation coefficient R and interpret its meaning. Let's do it. So you go to Stat, Calc, number 4. And R is 0.794. There you go. And not only we got R, we got the equation of the line, we got R squared. So let me just write them down here. So you don't have to go back. And the equation of the line.
For the part where we had to write the inequality, what inequality do we write?
Oh, not yet. He hasn't asked that. It's coming in part B.
Oh, okay.
I didn't use the linear regression t-test. If I did, then I need to know. But I used, the linear regression only.
Where is that? I couldn't find it.
Oh, here it's just stat, calc, not test. You don't go to test, calc.
All right, I got it.
It's number 4. That's a good question. As I told you, there are 2 functions, number 4, or you can go to the linear regression t-test.
Okay, got it.
That's good. Don't be shy, guys, of asking questions. I'm here to support you, so feel free to ask me anytime. There you go. I'm done with the calculator. That's all I need for now. Find the value of the correlation coefficient R. It's 0.794. If he asked me to interpret this, I would say there appears, I wouldn't say strong, very strong. I will say that it appears to be strong positive correlation between X and Y. Because it's not very close to 1, but it is close, 0.794. There appears to be strong positive correlation. Correlation means relationship, guys, between hours in traffic and gallons wasted. Okay, that's the first part. Now part B.
Why do you say that there's a strong positive correlation?
Because it's 79, 0.79. If it is close to 1, if it is very close to 1, you say very strong.
Oh, yeah, I remember now.
Yeah. If it is not, if it is 0.79 is close to 1, but not very close, we say strong, not very strong. There appears to be, oh, I forgot the word be here. The only way to tell whether there is a relationship is to do the hypothesis test. Now, at the 1% level of significance, test the claim that rho is greater than 0. Okay. He's making it clear to us. So he wants us to test the claim that rho is greater than 0. So this is your alternative hypothesis, guys. You're going to have HO, HA here. Rho is less than or equal to 0. Rho is greater than 0. And here you put correlation is significant. And here you put correlation is not significant. Always in the null hypothesis, not significant, and the alternative significant. And let's run the test. Stat, tests. Oops, I'm gonna scroll up. Linear regression t-test. Watch, guys. L1 is there, L2 is there, frequency don't touch, and we need greater than 0. You agree with me? He's asking us to test for positive correlation. So greater than 0. A student asked me about this, don't enter anything here. You don't need to enter anything and just hit calculate. T is 3.204. And the p-value is 0.0093. Okay, so let's do it over here. T is 3.203, 204. P-value is 0.009, and what the calculator, just to show you again, guys, 3. Do you guys agree that this is less than 0.01? So what's the decision? Reject. And can someone tell me what the conclusion is? There is enough evidence at the 1% level of significance to conclude that correlation means relationship, guys, is significant between hours and traffic delay and amount of gas wasted. That's it. Next question, guys. Predict the number of annual gallons consumed when X is 30 hours. How much gas would you have wasted if you spent 30 hours in a year in traffic delay? Well, you already have the equation, guys. It's right here. All you need to plug in the X equals 30 in here. So let's plug it in.
So the way it's written with y equals a plus bx is different than how you wrote it, which is ax plus b.
No, it's not, because he swapped the A and B in the linear regression t-test. So the A and B, I got them when I first did it, are swapped. They're exchanged. If you exchange them, you'll get the same equation again. You can look them up there. They are swapped, you know, so it will be the same.
Yeah, I got a different answer when I did it the first way.
Yeah, no, you want to do it the other way. So you want to swap, you know, just the A and B, then you will get the exact same answer.
Okay.
So it's 1.444 times 30 plus 2.814. So we get 46 gallons of gas wasted. Wow. So it's right here. I'll write it down. So this is the algebra, guys, where you need to do some algebra, plug in X values. 46.1 gallons. Okay, there's one more question missing, guys, here. What would be that question that we did in the previous, that it's not there? Find R squared and interpret its meaning. Well, you don't need to find it. It's already it's already displayed on the screen, 0.631. Here's how you interpret R squared. Change it to a percent, so it will be 63.1%. So you guys say 63.1% of the variation in the number of gallons wasted can be explained by the variation in the number of hours spent in traffic delay using the regression model. That's how you interpret this one. Now, I'm gonna ask you a question and I would like you to help me answer it. It's the same as part C. Predict the number of annual gallons consumed when X equals 50 hours. How would you do this? What would you do?
You plug in X.
You're technically speaking, you plug in X equals 50. But actually, we could not answer this question here. I cannot find what X equals 50. And I know now you're puzzled to say, what is he saying? You can just plug it. In particular, X equals 50, you cannot plug it in there to find, the number of gallons wasted. To give you a hint, guys, just look at the table first, and probably you can share some observation with me. So if he asks you to do X equals 50, you say that cannot be done.
Does it have to be within the numbers that we have there?
Exactly. Very good. Excellent. It has to be within the range of values that we have in X. The lowest value of X, guys, that we have is a 2, and the highest that we have is a 42. Anything he will ask you that's not be between 2 and 42, you will not be able to do it. You're going to see some exercises online. He gives you the equation and he gives you those tables. And then he'll ask you to find the X value when the Y value when X equals. He might throw in some value that doesn't fit inside the range. If it doesn't fit inside the range, you select the answer that you said that says that it can't be done. Is that clear? So it always, the X value has to be within the range of values given to you in the table. Okay. But these values are called the observed values. These are the actual values, guys. But when you use the equation to find some Y values are called the predicted values because you are using the equation to predict. Now, whether your predicted values are close to the observed values or not, that's a different story, but they should be very close because if your equation is good, the ones that you get from the equation should be close to the observed values. For example, we know if someone spends 24 hours in traffic delay, they're gonna waste 30 gallons. Let me see the equation if it gives me something similar to this, guys. So let me do that. It might be close, but not exactly 30 gallons. So let's see. 1.444 times, we say how much? 25 hours plus 2.814. You see, 30, but my equation gave me 38. Yes. So they're not going to be exact. So there is going to be a difference between what the equation gives you or what the actual values are. All right, guys. Now we're going to go and do this one right here. Your turn. So I would like you guys to take a minute and put your data values in L1 and L2 here. Sketch the scatter plot for the data and then find the correlation coefficient and interpret its value. Okay, let me show you how to sketch it. Zoom number 9. So you guys can agree with me, as the temperature rises outside, people tend to take more days off, number of absences increase because it looks like it's pointing up. Now he wants R. To find R, you just go to stat, calc. Oops, not number 5, number 4. Oh, it's very close to 1.98. And how do you interpret this?
There's a strong positive correlation.
Yeah, there appears to be very strong positive correlation between X and Y. Number 2, test for positive correlation between the temperature and the number of absences. Use alpha 0.01. I'm not going to use a critical value method. I'm going to use a p-value method. Okay, I'm going to do number 2 right here, guys. So HO, HA. Rho has to be greater than 0. And if you ask me why did I put this, because he says test for positive correlation. Correlation is significant. Correlation not significant. Always, always you write those two statements. That's what I like it to do for the assignment, which we're gonna go to next. Okay, I'm ready to use the calculator. There's nothing to do by hand here. So stat, tests, scroll up, guys. All right. And you can see F, take a note, it's F, linear regression t-test. L1, L2. Don't forget, guys, you need to change this before you hit calculate. I'm testing for positive, so I need to select the third one and calculate. Okay, T is 13.031. And look at the p-value, E minus 6. Don't ignore the E minus 6, please. It means it's almost 0. So T is 13.031. Step number 2. P-value, I'm going to put almost 0, which is less than alpha. And if it is less than alpha, guys, you reject HO. And if you reject HO, conclude that correlation is significant. It's as simple as that. There is enough evidence at the 0.05 level of significance to conclude that correlation is significant. Between temperature and number of absences. Now, maybe students will say, why we're doing the hypothesis test, since R tells us that there is a strong correlation. But remember, R tells us the story of the sample from within the sample only. This one row gives us the population story, the entire population story. So this one is more important than just finding R, because you extend, just your finding to the entire population. Find the equation of the regression line, guys. We already did it. It's right here. So I'm going to use now this one and show you it's going to be the same. He says y equals a plus bx, as you can see. And what did he say? A is negative 30.26. Let's do 3 decimal places. So negative 30.268. I'm not going to put X here because he says A plus BX. So I'm going to follow, just the pattern there. Plus, scroll down, and B is 0.449. X. That is the equation. What would be the number of absences in a given day if temperature was 95? Just plug in, 95 in there. So Y hat will be negative 30.268 plus 0.449 times 90. Okay. Let's see if we get something close to 10. If the temperature is 90, the number of absences according to the table was 10. This is called the observed value. Let's see if the predicted value will be close. It should be close because I got my R to be very close to to 1. So let's see. So we're gonna do it here. Negative 30.268 plus 0.449 times, what was it? 90. You notice, guys, it's 10.14, very close to 10 to the actual value. Why? Because your R was very close to 1. Remember, in the previous question, R was in the 80s, so it wasn't close to 1. So the closer to 1, the more the fit will be close to being perfect. So it's 10.1. Find the coefficient of determination and interpret its meaning, R squared. Well, you guys, you can square, just the value of R, 0.98, or you can get it off the calculator. So I'm gonna square it. There you go, 0.98 squared. I got 96%. Okay, how do you interpret this one? Let me interpret the meaning. 96% of the variation in, can someone complete this for me? What that mean? What do I say? 96% of the variation in what variable?
The number of absences.
Absent. Very good. In the number of absences. You start with Y again. Can be explained by the variation can be explained by the variation of the in the temperature. Using the regression line. All right. Okay. Last thing, guys, for this chapter, correlation and causation. I think it's important to understand what each one. Correlation means there is a relationship. You guys, you know that there is a relationship between smoking, tobacco, and lung cancer. Do you agree that there is a relationship?
Yes.
Yes.
But do you think that means that smoking will cause cancer for sure?
No.
No. So that's the difference between correlation and causation. The fact that two variables are strongly correlated doesn't mean that one will mean the other will imply the other. So yes, there is research that shows that there is strong correlation relationship between smoking tobacco and lung cancer. But that does not mean, just if you smoke tobacco, you're going to get, just lung cancer. That means smoking tobacco is going to cause lung cancer. There could be some other factors as well. So when there is a significant correlation between two variables, you should question whether one causes the other or vice versa. It doesn't mean that this is always the case. So just be careful, just about your understanding of relationships. Relationships, sometimes it could mean that one causes the other, but at other times it doesn't mean that one could cause, just the other to happen. The other thing that I would like to tell you, you might be asked in the book, just to find this one. When we did the linear regression t-test, guys, I'm going to show you this value that showed up. Let me just go back to the t-test. And I hit calculate. We got this value, let me scroll down, S, which is 0.9339. Let me tell you what S is. S is called the standard error of estimate. It is the standard deviation of the observed Y values about the predicted Y values. So it will give us, the amount of variation between the actual Y value and the predicted Y values that we use in the equation. It is given by SE. So if you are asked to find this value, you get it from the linear regression t-test. You can use your TI-84 to compute this value. The closer the observed values to the predicted values, the smaller the value of the standard deviation. Standard deviation measures the amount of variation. So if there is not too much variation, standard deviation will be low. If there is too much variation, the standard deviation is going to be high. So this is what S means. And with this one, I conclude chapter 9.